under 40 minutes, you are going to build a fully functional, real-world file-sharing application, and it is going to be production-ready. In this application, you can upload any file from your local system, whether it is a PDF or an image, and store it in the backend. You can also download and delete these files. However, to delete a file, a unique security code must be provided before the action is completed. The best part is that once a file is uploaded, anyone can access it from any device, whether a computer or a laptop, and download it as long as you share the website link with them. Every file uploaded will be stored on Cloudinary, so you will also learn how to integrate Cloudinary and MongoDB. Let us quickly preview how the application works. This is our application with a Select File button, and currently, no files are uploaded. When we click this Select File button and upload an image, a smooth animation plays for about 4 seconds, followed by a File Uploaded Successfully message that disappears after another 4 seconds. Afterward, you can see the file name, its size, the upload date, and both a download and a delete button. Clicking the download button successfully downloads the image. Now let us upload a PDF file. The animation plays, the success message appears, and the PDF named Landscape is uploaded. If we try to upload a file type that is not supported, the upload is rejected because the application only accepts PNG, PDF, and image formats with a maximum size of 10 megabytes. Even after refreshing the page, the data remains intact because it is permanently saved. If we open MongoDB, we can see all the file data, including names, URLs, public IDs, file types, file sizes, delete codes, and creation timestamps. On Cloudinary, we can also see the uploaded images along with their public IDs and full details. Now let us upload another image named Dark. To delete a file, clicking the Delete button brings up a clean pop-up where you must enter the correct code. If an incorrect code is entered, an invalid delete code message appears. However, once the correct code is copied from MongoDB, pasted in, and the Delete button is clicked, a brief animation plays and the File Deleted Successfully message confirms the file has been permanently removed. Refreshing MongoDB shows that only 2 files remain, the PDF and the other image, down from the original 3. You can delete the dark image as well using its corresponding code. That is our application, so let us get started right away. First, we will create a folder named Backend, then we will open a new terminal. Once the terminal is open, we will type cd backend to navigate into the backend folder. After entering the backend folder, we will run the command npm init-y. As you can see, the package.json file has been created. Next, we will run the command npm install Axios Cloudinary Cores.nv Express Mongoose Multer Streamifier to install all required dependencies in a single command. After the installation, we will run npm install-dnodemon to install it as a development dependency. Once that is done, we will open the package.json file inside the backend folder. Here, you can see all the dependencies we just installed are now listed. We will also change the main entry point to server.js. Below the main entry, we will add type module to enable ES module support. Inside the scripts section, we will define the start command as nodeserver.js and the dev command as nodemanserver.js. This completes the package.json configuration. Next, we will set up the folder structure. Inside the backend folder, we will create 5 folders. The first named config, the second controller, the third middleware, the fourth models, and the fifth routes. After that, we will create 3 files, a .env file, a server.js file, and an app.js file. Inside the config folder, we will create 2 files, cloudinary.js and db.js. In the controller folder, we will create a file named filecontroller.js. In the middleware folder, we will create uploadmiddleware.js. In the models folder, we will create file.js. And in the routes folder, we will create file route.js. This completes our folder structure. We will now close all files except server.js, app.js, and db.js. Next, we will visit MongoDB. You can sign up there. We will sign up using Google. After signing up, we will click on View All Projects and then click New Project. We will name this project Social Fast YT, but you can choose any name you prefer. We will click Next and then Create Project. Now we will click the Create button to set up a cluster and select the free plan. After clicking Create Deployment, we need to connect the cluster. We will click Create Database User, then choose a connection method and select Drivers. You will see a connection URL there. Copy that URL, go to your .env file, write mongo_URI equals, and paste the copied URL. Next, we will simply click the Done button. After that, we will write port inside the .env file and set it to 5000. Below that, we will add cloud_name, followed by API_key, and then API_secret. Now we will visit the Cloudinary website and log in with Google using the email of your choice. It may take a moment to sign in. Once logged in, navigate directly to API keys. Inside the API keys section, you will find your cloud name, API key, and API secret. First, copy your cloud name. In this case, it is Frontend-Mastery, and paste it next to cloud_name in the .env file. Then copy your API key, which will be a numeric value, and paste it next to API_key. For the API secret, click the eye icon, which will trigger a verification step. A 4-digit code will be sent to your email. Go to your email, copy that code, paste it into the verification field, and you will then be able to copy your API secret. Paste it next to API_secret in the .env file. Do not share this secret with anyone. After this, we will close the .env file and open db.js. In db.js, we will first import Mongoose. Below that, we will define an async arrow function named connectDB, which contains a try-catch block. The catch block receives an error parameter. Inside the try block, we will define a variable named con that awaits the result of connecting Mongoose to the URI stored in process.env.mongo_URI. Below that, we will log a success message. MongoDB connected, followed by the host name retrieved from con.connection.host using a template literal. Inside the catch block, we will use console.error to log DB connection failed, along with the error message. Below that, we will call process.exit with a value of 1 to terminate the process on failure. Finally, we will export connectDB at the bottom. This completes db.js. Now we will configure server.js. First, we import .env and immediately call .env.config to load environment variables. Then we import app from app.js and import connectDB from db.js. Below that, we define a constant named port, which reads from process.env.port and falls back to 5000 if no value is set. Below that, we call connectDB to establish the database connection, and then call app.listen, passing the port value and an arrow function that logs server running on port, followed by the port number in a template literal. After this, we will open app.js. Here, we will first import Express. After importing Express, we will initialize it by calling Express and storing the result in a variable named app. Then we will call express.json inside app.use to enable JSON parsing, and we will export app at the bottom. Now open the terminal and run the command npm rundev. Our server is running successfully, MongoDB is connected, and there are no errors. Close the terminal. Next, open the file.js file inside the models folder. We will first import Mongoose. Below that, we will define a variable to hold a new mongoose.schema. Inside the schema, we will define a file name field as an object with type string, required true, and trim true. Below that, we will define a file URL field as an object with type string and required true. Below that, we will define a public_ID field, also with type string and required true. Below that, we will define a file type field with type string and required true. The file type field will also include an enum array containing the values image, PDF, docs, audio, and others. Below that, we will define a file size field with type string and required true. Below file size, we will define a delete code field with type string and required true. Below these field definitions, we will set timestamps to true. Then we will define a variable named file that calls mongoose.model, passing the string file along with the schema. Finally, we will export it as file. The file.js model is now complete. Next, we will open cloudinary.js inside the config folder. First, we will import .env and call .env.config. Below that, we will import v2 as cloudinary to use the latest version. Then inside cloudinary.config, we will set cloud_name to process, .env.cloud_name, API_key to process, .env.api_key, and API_secret to process .nv.api_secret. Finally, we will export cloudinary at the bottom. This completes cloudinary.js. Next, we will open filecontroller.js inside the controller folder. First, we will import Axios, Cloudinary, the file model, and Streamifier. After these 4 imports, we will define a helper variable named getFileType as an arrow function that accepts a MIME type parameter. Inside this function, we will write an if statement. If the MIME type starts with image, we return image. Below that, we write another if statement. If the MIME type strictly equals application/PDF, we return PDF. Below that, we return other as the default. Below this, we will export an async function named uploadFile that accepts rec and res as parameters, containing a try-catch block with error in the catch. Inside the try block, we will define a constant named file equal to rec.file. Below that, we will write an if statement. If the file does not exist, we return res.status400 and send a JSON message of no file uploaded. Below the if statement, we will destructure 4 values from the file object: original name, MIME type, size, and buffer. Below that, we will define a variable named fileType by passing MIME type into the getFileType function. Below that, we will define a variable named deleteCode equal to math.floor of 1000 plus math.random multiplied by 9000, then converted to a string using toString. This logic generates a random 4-digit number. Below that, we will define a variable named result that awaits a new promise. Inside the promise, we receive resolve and reject. Inside this function, we will define a constant named stream equal to calling cloudinary.uploader.upload_stream, passing an object where resource_type is set to auto. This method accepts a callback with error and result parameters. If there is an error, we call reject with the error. Otherwise, we call resolve with the result. Below that, streamifier.createReadStream converts the buffer into a readable stream and pipes it into the upload stream. Below that, we will define a variable named newFile that awaits file.create, passing an object with file name set to original name, file URL set to result, .secure_URL, public_ID set to result.public_ID, along with file type, file size set to size, and delete code. After that, we set res.status to 201 and send a JSON response with the message file uploaded successfully, along with the new file and delete code. In the catch block, we set res.status to 500 and send a JSON message of upload error. Below that, we will export an async function named getFile that accepts req and res. Inside the try block, we define a constant named files that awaits file.find, chained with sort by created at in descending order. Then we set res.status to 200 and send the files as JSON. In the catch block, we set res.status to 500 and send a JSON message of failed to fetch files. Next, we will define and export an async function named download file below, accepting rec and res as parameters. Inside this function, we will have a try-catch block with error in the catch. Inside try, we will destructure ID from rec.params. Below that, we will define a variable named file that awaits file.find by ID, passing in the ID. Below that, we will write an if statement. If the file does not exist, we return res.status404 and send a JSON message of file not found. Below that, we will define a variable named response that awaits axios.get, passing in file.file URL, along with an options object where response type is set to stream. Below that, we will call rs.setHeader to set the content-disposition header to attachment, with the file name set to file.filename inside a template literal. Below that, we pipe response.data into reads. In the catch block, we use console.error to log download failed, along with the error, then set res.status to 500 and send a JSON message of download failed. After that, we will define and export an async function named delete file below, accepting rec and res as parameters. This function will contain a try-catch block. Inside try, we will destructure ID from rec.params, and below that, destructure code from rec.body. Below that, we will define a variable named file that awaits file.find by ID, passing in the ID. Below that, we will write an if statement. If the file does not exist, we return a res.status404 and send a JSON message of file not found. Below that, we will write another if statement. If the code does not match file.delete code, we return res.status400 and send a JSON message of invalid delete code. Below that, we will await cloudinary.uploader.destroy, passing in file.public ID to remove the file from cloudinary. Below that, we await file.find by ID and delete, passing in the ID to remove the record from the database. Below that, we set res.status to 200 and send a JSON message of file deleted successfully. In the catch block, we set res.status to 500 and send a JSON message of delete failed. This completes filecontroller.js. We will now close this file and open upload middleware.js inside the middleware folder. In upload middleware.js, we will first import Malter. Below that, we will define a variable named storage by calling malter.memorystorage, which stores uploaded files directly in memory as a buffer. Below that, we will define a file filter arrow function accepting arico, file, and cb as parameters. Inside this function, we will define an array named allowed types containing the accepted MIME types, such as image formats and PDF. Below that, we will write an if statement. If allowed types includes the file's MIME type, we call cb with null and true to accept the file. In the else block, we call cb with a new error stating file type not allowed, along with false to reject it. After that, we will define a variable named upload equal to Malter, passing in an object with storage, file filter, and limits. The limits object will include file size set to 10, multiplied by 1024 multiplied by 1024, which equals approximately 10 megabytes. Finally, we will export the upload variable. This completes upload middleware.js. Next, we will close this file and open fileroute.js inside the routes folder. Here, we will first import Express. Then we will import upload file, get file, download file, and delete file from filecontroller.js inside the controller folder. Below that, we will import the upload middleware. Below this, we will define a router variable by calling express.router. We will then define a post route at /upload using upload.single to handle a single file upload connected to the upload file controller. Below that, we will define a get route at /connected to get file. Below that, we will define a get route at /download /ID connected to download file. Below that, we will define a delete route at /ID connected to delete file. Finally, we will export the router. This completes fileroute.js. Now we will open app.js. After opening app.js, we will import cores and file routes. After these two imports, we will add app.use with cores to enable cross-origin requests. Then, above the export statement, we will add app.use with the path /API/files mapped to file routes. Our server is now running correctly with no errors. This concludes the backend code. Next, we will begin writing the frontend code. Before starting the frontend, we will first create a folder named Frontend. After creating the folder, we will open a new terminal and type the command cd frontend, then press enter to navigate into the frontend folder. Then we will type the second command, npm create vitae at latest, followed by a space and a dot, and press enter. After this, we will enter Y, and then in the select framework prompt, we will choose React, and in the variant prompt, we will choose JavaScript. We will then select Yes for install with npm and start now. After the installation, copy the local URL, localhost 5173, and open it in any browser. After this, we will open a new terminal and type the command to install Tailwind CS, Vitae, Axios, Lucide React, React, React DOM, React Icons, and React Router DOM all at once. Simply type the command shown on screen and press enter. After installing all these packages, we will do a small cleanup in the frontend folder. We will delete app.css, remove the counter code from app.jsx, and clear the code from index.css. Then, inside the src folder, we will create 5 folders. The first named Components, the second Hooks, the third Pages, the fourth Services, and the last Utils. After this, inside the Components folder, we will create 3 files: deletemodal.jsx, filecard.jsx, and uploadbox.jsx. In the Hooks folder, we will create a usefile.js file, and in the Pages folder, we will create a home.jsx file. In the Services folder, we will create a file service.js file, and in the Utils folder, we will create a file named formatfilesize.js. This completes our front-end folder structure. After this, we will close all open files and keep only fileservice.js open. There, we will import Axios and then define a variable named API that holds our base API URL http://localhost:5000/API/files. Below this, we will export an async function named uploadFile that accepts form data as a parameter. Inside this function, we define a variable named res that awaits axios.post, targeting the upload endpoint using a template literal with the API variable. After that, we pass in form data and set the content dash, type header to multipart/form-data inside an object. Below the res variable, we return res.data. Below this, we export another async function named getFile. Inside this function, we define a variable named res that awaits axios.get, passing in the API variable and return res.data below. Below that, we export another async function named deleteFile, which accepts ID and code as parameters. Inside this function, we define a variable named res that awaits axios.delete, targeting the endpoint using a template literal with the API variable and the ID. After this, we pass an object containing the code as the request data. Below the res variable, we return res.data. This completes the fileservice.js file. After this, we will close the service file and open use file.js inside the hooks folder. There, we will import useState, useEffect, getFile, uploadFile, and deleteFile. Below this, we define an arrow function named useFile. Inside this, we define a state variable, files and set files, initialized as an empty array using useState. Below that, we define a loading state, loading and set loading, initialized to false using useState. Below that, we define a success state, success and set success, initialized to an empty string using useState. Below that, we define an error state, error and set error, initialized to null using useState. Below these state declarations, we define an async function named fetchFiles. Inside the try block, we set loading to true and error to null. Below that, we define a variable named data that awaits the getFile function and call setFiles with data below it. In the catch block, we receive the error and call setError with the error response message, falling back to the string failed to fetch files. In the finally block, we set loading to false. Then at the bottom, we define a constant named handleUpload, which is an async function that accepts form data as a parameter. Inside the try block, we set loading to true, error to null, and success to an empty string. Below that, we define a variable named data that awaits upload file passing in form data. Then we call setFiles with a callback, receiving the previous state as prev and returning a new array that spreads data.file followed by prev. Below that, we call setSuccess with data.message. In the catch block, we call setError with the error response message, falling back to the string upload failed. In the finally block, we set loading to false. After this, we define another async function named handleDelete, which accepts ID and code as parameters. Inside the try block, we set loading to true, error to null, and success to an empty string. Below that, we await delete file passing in ID and code. Then we call setFiles with a callback, receiving the previous state as prev and filtering out the file whose underscore ID does not equal the given ID. In the catch block, we call setError with the error response message, falling back to the string delete failed. In the finally block, we set loading to false. Below this, we take a useEffect hook containing an if statement. In the if statement, we check if success or error exists. Inside this block, we define a constant named timer equal to setTimeout, inside which we set success to an empty string and error to null after 4,000 milliseconds, which is 4 seconds. Below that, we return a cleanup function that calls clearTimeout with the timer variable. At the end of the useEffect, we include success and error in the dependency array. Below that, we define another useEffect that calls fetchFiles with an empty dependency array so it runs only once on mount. Below that, we return an object containing files, loading, success, error, an upload property mapped to handleUpload, a delete file property mapped to handleDelete, and a fetch property mapped to fetchFiles. Below that, we export useFile. This completes the code for useFile.js. After this, we will open the format filesize.js file in the utils folder. Here we define an arrow function named formatFileSize that accepts bytes as a parameter. Inside this function, we write an if statement. If bytes is less than 1024, we return bytes concatenated with the string b in uppercase. Below that, we write another if statement. If bytes is less than 1024 multiplied by 1024, we return bytes divided by 1024, with the result fixed to 2 decimal places using toFixed, concatenated with the string kb in uppercase. Finally, we return bytes divided by the product of 1024 multiplied by 1024, fixed to 2 decimal places, concatenated with the string megabytes in uppercase. Below this, we export format file size. After this, we will close this file and open deletemodal.jsx. Inside deletemodal, we import useState, and below that, we define an arrow function named deletemodal. Inside the function parameters, we destructure isOpen, onClose, and onConfirm. Inside deletemodal, we define a state variable, code and setCode, initialized to an empty string using useState. Below that, we write an if statement. If isOpen is false, we return null. Below that, we define an arrow function named handleSubmit. Inside this function, we write an if statement. If the code length is not equal to 4, we display an alert saying enter 4-digit code and return. Below the if statement, we call onConfirm with code, then call setCode with an empty string, and finally call onClose. In the return statement, we render an outer div. Inside this div, we render another div, and inside that, an h2 tag with the text enter delete code. Below this, we render an input of type text with a maximum length of 4, its value set to code, and an onChange handler that uses an arrow function with parameter e to update the code via e.target.value. In the placeholder, we write the password symbol. Below the input, we render a div containing a button with the text cancel, where onClick calls the onClose function. Below this, we render another button with the text delete, where onClick calls the handle submit function. Below this, we export delete modal, completing the code for deletemodal.jsx. Next, we will open the filecard.jsx file. In this file, we import format file size and the file text, download, and trash icons from Lucide-React. Below this, we define an arrow function named filecard, destructuring file and open modal from the props. In the return statement, we render an outer div containing a second div, inside, which is a third div. In this third div, we render the file text icon. Below the file text icon, we render a div containing an h3 tag that displays the file's name dynamically using file.filename. Below this, we render a paragraph tag that calls format file size, passing in file.filesize. After closing two divs, we render a paragraph tag below. Inside this paragraph tag, we render a formatted date by calling newDate with file.createdAt and chaining to local string. After closing one div, we render another div containing an anchor tag. Inside the anchor tag's href, we use a template literal to construct the download URL, http://localhost:5000/API/files/download, followed by the file ID. Below this anchor tag, we render the download icon. Below that, we render a button that displays the trash icon, with an onClick handler using an arrow function that calls openModal with the file ID. Finally, we export filecard, completing the code for this file. After this, we will open uploadbox.jsx. First, we import the folder up icon from Lucide-React. Then, we define an arrow function named uploadbox, destructuring on upload from the props. Inside this function, we define an arrow function named handleChange that accepts parameter e. Inside this function, we define a constant named file equal to the first file from e.target.files. We then write an if statement. If the file does not exist, we return and do nothing. Below this, we define a formData variable by calling new formData, then use formData.append to attach the file under the key file. Below this, we call onUpload, passing in formData. In the return statement, we use a fragment containing an h2 tag with the text upload your file. Below this is a div that renders the folder up icon followed by a paragraph tag stating the maximum file size is 10 megabytes. Below that is another paragraph tag listing the supported formats: PNG, PDF, and JPG. Below this, we render a label with the text select files, and inside the label, an input of type file. The onChange handler calls handleChange, and the input is set to hidden. Finally, we export uploadbox. Then, in the Pages folder, we open home.jsx. Here, we import useState, uploadbox, filecard, delete modal, and useFile. We define a home arrow function and call useFile inside it. From useFile, we destructure 6 values: file, upload, delete file, loading, error, and success. Below this, we define a state variable, isOpen and setIsOpen, initialized to false using useState. We define another state variable, selectedID and setSelectedId, initialized to null using useState. After this, we define an arrow function named openModal that accepts an ID parameter, calls setSelectedID with ID, and calls setIsOpen with true. Below the openModal function, we define another function named handleDeleteConfirm, which accepts a code parameter. Inside this function, we call deleteFile with selected ID and code. In the return statement, we render an outer div containing a second div where we render the uploadBox component and set its onUploadProp to the upload function. Below this, inside a conditional block, if loading is true, we render an empty div to indicate a loading state. Below that, if success exists, we render a paragraph tag displaying the success message. Similarly, if error exists, we render a paragraph tag displaying the error message. Below this, we render an h2 tag with the text recent files, followed by a paragraph tag with some descriptive text. Below this, we render a div where if files.length is 0, we render a paragraph tag with the text no files uploaded yet. Otherwise, we render a fragment containing a div with 3 span elements for file name, date uploaded, and more info. After closing that div, we render another div containing a files.map call, where for each file we render the file card component. In the file card, we pass the file ID as the key, the file object as the file prop, and the openModal function as the openModal prop. At the very bottom, we render the deleteModal component. Inside this, we set the isOpen prop to isOpen, the onClose prop to an arrow function that sets isOpen to false, and the onConfirm prop to the handleDeleteConfirm function from above. At the bottom, we export home. This completes our home.jsx code. Now we will close this file and open app.jsx. There, we will import home and create an app function that returns the home component, then export app. There is a small error in deleteModal. It appears that const was used instead of import for useState from React. Let us fix that to a proper import statement. There was also an incorrect require used for React. Now the code is running successfully and you can see the live preview in the browser. For styling, we will use Tailwind CSS, which is already installed. In the src folder, we will open index.css and add the Tailwind CSS import directive at the top. Below that is some additional code for the loader animation. You do not need to write this manually. You can simply download it from the GitHub repository. Then we will open vite.config.js, import Tailwind CSS from the Tailwind CSS Vite package, and call Tailwind CSS inside the plugins array. After that, we will apply styles to the deleteModal. All this styling code is also available on GitHub, so there is no need to write it manually. Just download it from there. Styling is now complete, and as you can see, the application has a clean, modern look. Let us now test the application. First, we will click the Select File button, choose an image, and it will process for a moment. You can see the message File uploaded successfully. After this confirmation, the file data appears below. Now we will select and upload a PDF, and that is also uploaded successfully. Our application is working perfectly. Next, we will open MongoDB. There, you can see the data for both uploaded files has been stored. You can also see the delete code, and for example, 1392. Then we will open Cloudinary and navigate to images. Under recent uploads, you can see the image we uploaded is there. Cloudinary handles large file uploads quickly, which is why we use it. Our application is working correctly end to end. If you found this video helpful, please give it a like and subscribe to the channel so you do not miss future videos. That is all for this video. If you have any suggestions for a future project or run into any issues, please leave a comment. Thank you for watching, and I will see you in the next video.